We want to solve the recursive relation a sub n is equal to 3 times a sub n minus 1 minus 1, given that a sub 1 is 1. So the way we're going to do this is by working recursively on the previous term here, the a sub n minus 1. We want to get it all the way down to a sub 1. So we're going to substitute a sub n minus 1 with 3 times a sub n minus 2 minus 1, because basically what we do here is substitute n is equal to n minus 1 to get to this. And then we're going to simplify, so we're going to distribute the 3 and get 9 times a sub n minus 2 minus 3 minus 1. And it's probably better to think of 9 as just 3 squared. Okay, now let's work on a sub n minus 2. We plug in n equals n minus 2 in this formula. We get 3 times a sub n minus 3 minus 1. Again, distribute. And then we have 27 times 8 sub n minus 3 minus 9 minus 3 minus 1. And so here we have a pattern. Basically, it's like 3 to the 0, 3 to the 1, 3 to the second, and then 3 cubed. So yeah, I'm just going to rewrite it like this. And now if I do this until we get to a sub 1 here, well, notice that this is always going to be n minus the exponent of the 3, of this guy right here. Okay, so if this is 1, so 1 is going to be n minus the exponent of 3. So that means the exponent of 3 is n minus 1. So this is n minus 1, this is 1. And then notice here that this 2 is always going to be 1 less than this exponent. So it's like 1 minus 3 squared. The exponent is n minus 2, so we're going to go 1 less than that, which is n minus 2. Okay, now I can substitute a sub 1 equals 1. And I'm going to factor out the negative from here. And so this is going to be a geometric series, a finite geometric series. So basically what you do is the first term minus the omitted term divided by 1 minus the ratio. So the first term is the 3 sub n minus 2. The omitted term is if you were going to go one step further than this 1, that would just be 1/3 because the ratio here is 1/3. And so this is what you get. So first term minus the omitted, I just put it as 3 to the negative first power, and then 1 minus the ratio. Now I can multiply by 3 over 3. So this 3 distributes to both of these guys to become 3 to the n minus 1 minus 1, and then 3 in the denominator here. That's 3 minus 1, which that just becomes 2. And then I can split this fraction up into 2 different fractions. Recall that this negative is being applied to the 3 to the n minus 1 and the negative 1. That's why this becomes positive 1/2. And so when I simplify, I get 3 to the n minus 1 over 2 plus 1/2, which I can bring it all together and get this as my final answer.